Today, super baby lesson. I gave it to you. Inverse of quadratics. We've already talked about inverses, so that's why I'm keeping it short and sweet. So we're just going to practice specifically quadratic inverses. That's it. Right? So the inverse of a function is what? What did we say it was? What kind? It's the opposite. Undoes what the original function does. Or we said it's a special reflection in what? Close. Reflection in y equals x. That diagonal line. Basically like a line with slope 1 going through the origin. And when we talked about inverses in Unit 1, way back, how do you find the inverse if you're given an equation? Yeah, Lucas? Swap x and y, and then solve for y. Or isolate. Solve/isolate for y. Boop. If I'm given coordinate points, I just flip them. Ooh, I'm going to say swap xy to yx. That was your inverse question on the test too. It gave you a point on the inverse. All you had to do was flip it and then plug it into the equation, since that would be for the original. Right? So that's all. So it's a lot of swapping, undoing, doing the opposite. The same thing applies for quadratics. So okay, if I'm doing the original parent function, which I'll do the parent function in pink. I'm feeling kind of like Barbie, right? Right. I'm feeling Barbie, hot pink, right? So x squared, right? That's starting at 0, 0, and then step pattern. Do we remember step pattern? This is from 3.1. Over 1, up 1. Remember, odd numbers. You're going up by odd numbers. Then over 1, up 3. And then over 1, up 5. Do I have it right away? Oh, no. I'm so close. It would be like right there. Right? Or just square your x value. So you'd be like, okay, -2 squared, 4, -1 squared, 1, 0 squared, 0, 1. And then you notice it's a reflection, right? 1 squared is going to be 1, 2 squared is going to be 4. And you'll always have that like mirror. So, okay, there's our original. If I'm trying to find the inverse, and we're given this equation, okay, we're saying y equals x squared. I need to now swap x and y. So x equals y squared. If I want y by itself, what do I got to do to this? How do I undo a square? Square root. Exactly. Sorry, I'm in a silly, goofy mood today. So the plus minus square root of y, which just basically means like it's going to be a sideways parabola, right? So if I want to do this like by flipping points, you could try graphing this as doing like a square root function here and then a square root function like reflected. Or if you're like, miss, I do not remember the square root function, I do not remember reflections, that's fine, just flip the points. 0, 0 flipped is just going to be 0, 0. 1, 1 flipped, still 1, 1. -1, 1 flipped? What's that going to be? 1, -1. Right? This guy, we're at 2, 4. So if I flip that, that's 4, 2. Same thing. -2, 4. 4, -2. And then you'll notice, whoa, she's sideways. Voila. That is your inverse of a parabola. And that line, y equals x, is like basically like this dotted line here. That's the reflection. That's what's causing the x and y values to kind of like swap places. Very pretty. And then we said that there's like kind of like special stuff with like the domain and range. So like if I'm just looking at the pink function, the original, what's my domain for the pink? What can all the x values be? Anything. So XER, it's going to keep going up and up and up and up forever and eventually touch everything that's x. And then y's, do I got any sort of restrictions of y can be or can't be?
Y can only be greater than 0.
Yeah, it's like my vertex is at 0 and then I only go up. I'm never going to go into the negative. So we're going to say YER such that y is greater than or equal to 0. And then the inverse, we said domain of the original becomes the range of the inverse. Here, wait. I want to do this in pink so it's Barbie. Here. Color. Hot pink, just to match it so we know which one we're talking about. And then my blue. So we said domain of original now becomes range of the inverse. And vice versa. The range of the original becomes the domain of the inverse. So now I'm just flipping them. I'm basically like trading places. Which if I look, yeah, for my x values, I can only start at 0 and go into the positives. I'm never going to go into any negative x values. And then my y values, I'm extending this way forever and ever and ever. So I'll touch everything. I'll touch every y value, right? So they flip. Is the inverse of f at x equals x squared a function, or is it a relation? It's a relation. Why? It doesn't what? You said it doesn't put. It doesn't pass the vertical line test. Relation. Fails VLT, not BLT, right? If I run my pencil through this, I am touching two x values at once. It is not a function, and that is like true for everything onwards, right? It's touching 2 points always. So it fails vertical line test. It's not a function. So if the original quadratic function opens upwards, so if a is positive, then the inverse is going to open to the right, kind of like how we see on this graph. Versus if it was frowning and opening downwards, it would be opening to the left. Yeah, Lucas?
So, is the inverse function relation, like, you write it as y squared is equal to x? Or should we write it as square root of x is equal to y?
Plus minus square root of x.
Just y squared equal to x.
Because we want to isolate y. The function's in terms of y. Would you say like f of x squared for an equation? That's why. You want to isolate y. Y has got to be by itself. That's why. Right? So if it's frowning downward, then it would open to the left like this way. Right? And that's kind of like your reflection. First page, donezo. Are we still copying? Do we need time? Yeah? Okay. Do we have any questions about this so far? Or is this kind of like rejogging your memory all the way from Unit 1? Are we okay? Over in this table? We're okay at this table? Back table? Good luck. Everyone wish Keen good luck. Good luck. Good luck. Manoli raised a great point that because Miss Zambri was lazy and copy and pasted this when I was making the handout at 11 o'clock last night, it should say downwards. Okay, let's get into practicing. So if I give you an equation for a parabola, and it's going to be in vertex form, not ugly standard form. It's going to be in vertex form. I want you to find the inverse of this function. So step 1. I'm going to just replace f at x with y, so I know which one's y and which one's x. So that's all I'm doing. X plus 1 squared plus 4. And then I will swap x and y. So all I'm doing is trading places with y and x. I'm just swapping where they are in the equation. Coolio?
Yes.
Cool. Now, we always do stuff bedmass way. We're going to do reverse bedmass, right? So usually we start with exponents. No. At the end is adding and subtracting. So we're going to move this first, right? You're going in reverse order. Remember, we're doing reverse. So first we're going to move the constant. If you have a plus or minus anything, that's what you're going to move first. So now if I move that over to the other side, this is going to be minus 4. So x minus 4 equals negative 2 y plus 1 squared. Next up in reverse bedmass, multiplying and dividing. I've got to times by negative 2. I got to undo it, so we're going to divide by negative 2 on both sides. Did I just blow your mind? You were like...
I was just thinking of that.
So all I did was just divide by the coefficient in front. That's all I did. Right? So, okay, now I'm going to have this. I'm going to just say x minus 4 all over negative 2, and we're just left with y plus 1 squared. Next up in reverse bedmass is the exponent, right? Undoing a square means I square root plus minus square root. So now I've got this plus minus square root of x minus 4, negative 2. is equal to y plus 1. Now I freed up whatever's in my brackets, the b, the start of BEDMAS. So now I can move over the 1 to the other side. So now the inverse is plus minus square root x minus 4 all over negative 2 minus 1. That's your whole function. I know, it's so ugly, right? So even if you want to do the notation to say this is equal to f inverse of x, that's the end, right? So it's reverse BEDMAS, do opposite. A lot of people go into doing this first because they're like, it's in front, it's the coefficient, I have to divide it out. But then what about this guy, right? Then it gets left over. So always reverse BEDMAS. Start from, basically from like right to left. We always do stuff left to right, but right to left in this case kind of works. Is there anything about these steps that we want to like run through again? Why we did what we did? We're okay? We're okay? Do we need to run through it one more time? No, we got it? Back table? We're all good? Yay. I start doing grade 10. Thumbs up, thumbs to the side, thumbs down. Show them, right? Maybe you can try this one on your own. Maybe we take the training wheels off. It's doing the same thing. Find the inverse, and then it's just saying graph the parent function and the inverse on the same grid. So you're going to do the same steps like we did here, but now with this equation, this 2x plus 3y squared minus 4. And then you're just going to graph it, right? And graphing it, just flip your parent points.
Yeah.
Do you want to try it? Take a couple minutes. Even just attempt to find the equation, and then we graph together. For this question, we're going to do it together, Bridget. So, okay, for my inverse, step 1, I'm going to do it on the side here. So y equals 2x plus 3 squared minus 4. And now I'm just going to swap x and y. So I'm just trading places, right? Reverse BEDMAS, I got to move the coefficient first. So now this is going to be x plus 4 is equal to 2y plus 3 squared. And then again, coefficient in front, I got to divide that out. So now I'm going to divide by 2. And so I've got x plus 4 divided by 2. And I've got it equal to y plus 3 squared. I got to undo that square, so I'm going to square root, plus minus version. And that's going to undo the square. You don't have to square root y or 3. It's just saying like that bracket is squared. So you can just get rid of the square. That's all. So then last step is if I've got this square root x plus 4 over 2 equals y plus 3, I can move the 3 over. So our inverse function is going to be equal to square root of x plus 4 over 2 minus 3. That's our inverse equation. Now, Lucas was saying, I don't need this to graph, which, no, you don't. It's a last case resort. You can use it to graph if you want to, but it looks kind of yucky. So the easiest way to do it is let's graph the parent or the original and then flip the points. So, okay, I'm going to do light blue for my original function, f at x. So vertex is at -3, -4. We always flip the sign of this one on the inside. So it is at -3, -4, not 3, -4. And then my step pattern. Some people were confused by this. If we have a coefficient in front, I got to change my step pattern. So instead of going up 1 over 1, up 1 over 3, and up 1 over 5, which, let me write this, over 1, up 1, over 1, up 3. We're just going up by odd numbers. You're going to times whatever you're going up by whatever your A value is. So I'm going to times these all by 2. So now instead of going over 1, up 1, I'm going up 1, or over 1, up 2. Over 1, up 6. Over 1, up 10. Right? So I can do that. So over 1, up 2. Over 1, up 6. 1, 2, 3, 4, 5, 6. And then that's all I can fit. Now to graph the inverse, all you have to do is just flip these points. That's it. You can use your equation if you want, but it's kind of yucky, right? We said. So -3, -4 is going to become -4, -3. I've got -2, -2. That flipped is just still -2, -2. -4, -3 becomes -3. Whoop. Where's my second point? -4, -2. Sorry, becomes -2, -4. And then my top one's up here. -1, 4 becomes 4, -1. And -5, 4 becomes 4, -5. All right, so I'm just flipping. And then you'll see, oh, it's a sideways parabola. So they won't always share the same vertex, like in like the original one that we did, like for x squared and then square root of x, where they shared the same vertex. Whoa. In this case, you can see the vertex is still like mirrored. All right, so it's flipped. And then the last bit for stating the range and domain of this function, what is the domain and range? The domain is going to be what? I got some restrictions of what x can be. What? Yeah, Lily? Yeah. What are my domain? What are my x values allowed to be?
Greater than -4.
That's true. Because I'm starting at -4 here, and then I'm only going into the positives. I'm only getting greater. I'm not going anything less than -4. So we'll say x is going to be greater than or equal to -4. And then my range, any restrictions on y? No, it's just going to keep getting wider and wider and wider and eventually hit everything. So just YER. Voila. And that's it. You graphed a quadratic inverse. And it's original. And you stayed domain and range. Voila. So I told you, this was like a little baby unit. Since like we already did inverses, this is just the inverse of a quadratic specifically. We're not going to get into the inverses of the other ones. So that's it. There's a couple questions. Literally, this is all the homework that I screenshotted. I'm only going to do like algebraic stuff or graphing stuff with the inverses. We're not going to do any word problems for inverses.